Okay, I'm going to go next and just do another one of my videos redone. We're going to look at the exact values. I'll try and write nice and big. Now, with this one, you need to know your surds a little bit. But I'm going to explain where they came from, because I think, again, if you understand it, it just makes, when you work with it, a lot clearer and you'll remember it. My technique for studying is you need to understand it and then to memorize it. So let's have a look. This one is based on an equilateral triangle of length 2. Now we all know with an equilateral triangle all the angles are equal, and so it's 180 divided by 3, they're all 60. And then what we do is we bisect for an equilateral. It will cut it in half, so that 2 becomes a 1, my 60 becomes a 30. And then we can get rid of this and work on this. So this is where this comes from. Sometimes you don't get explained that, but I like to explain it because I think it makes more sense. Hopefully I haven't moved that out of the way too much. Not too bad. Hopefully you can see all that. Now if we look at this, we use Pythagoras' theorem because I've got two sides and an unknown. You should be able to do that very nicely. That should become root 3 because c squared equals a squared plus b squared. My little rule is that is always your c. My unknown I make as a and b. So a equals a, b equals 1, and c equals 2. So we get that 2 squared is equal to a squared plus 1 squared. I don't do any of the working out until the last line. I like to rewrite, and then I move that across, showing every single little bit of working out, which is really annoying, but you can get extra marks. The inverse of squaring, as we know, is the square root of 2 squared minus 1 squared, which is 4 minus 1, which is root 3. That's where the root 3 comes from. But you don't really need to know that. That's just a little oops, going into that. The main thing is you should be able to draw this with your eyes closed 24/7. And the way I like to do it is this. I go 1, 2, 30, 60, and the root 3 is linked to the 30. So that's one of your exact triangles. The other one is based on the unit circle, which is an isosceles triangle of the 1 unit length. And again, if it's isosceles, that's 90. This has to be 45. And again, through Pythagoras, that becomes root 2. So again, that's where those exact values come from. So now, let's have a look. When we apply this to our beautiful trigonometric circle. So the first thing you do when you get to an exam, you go 60, 30, 1, 2, root 3, and 1, 1, and root 2. So you should just know them. They're not given on the exam. Just draw them on as soon as you sit down and can touch your pens. So looking at this, now what I didn't do with this circle before is work out why all students take chemistry, why sine is only positive here, tan's only positive there, cos is only positive there, but they're all positive here. And remember that's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And going back to here, theta. So just keep on drawing this over and over and over again until you just sit there and do it. Now that's 0, 90, which is pi over 2, pi or 180, 270 or 3 pi over 2, and 2 pi. So if you remember last time, we had a look at this is 1, 0, 0, 1, minus 1, 0, and 0, minus 1. If you remember that, when you're doing the y and the x, they're all positive here because they're both positive x and positive y. If you look at quadrant 2, it's positive y, and remember sine of theta is y, cos of theta is x, and tan of theta is y over x. So here in quadrant 2, x is negative, which means cos is negative, and it's divided by a negative x, so tan is negative. But y is positive. In quadrant 3, x is negative and y is negative. So that's negative and negative, but a negative divided by a negative makes tan positive. And likewise here, in quadrant 4, y is negative, but cos is positive. And here, if y is negative means sine's negative, negative over a positive makes tan negative, and cos then is positive because that's positive x in that one. So that's where that comes from. But again, understanding it is fine, but just writing, all students take chemistry, all are positive, sine's positive, tan's positive, and cos is positive. So remember the last time I said this way is always 180 minus theta. This way is always 180 plus theta. And think of it, when we start going backwards for negative theta, we're going from 180 and we're going closer to 0 this way. This way we're getting further away from 0, so we're adding theta. And here, this way, will be 360 minus theta. Now we can work out sine, cos, and tan for these ratios. Now if it was here, if we have a look at sine of 30 is opposite over hypotenuse, which is 1 over 2. Cos of 30 is adjacent over hypotenuse, which is root 3 over 2. And tan of 30 is opposite over adjacent. The opposite is 1 over root 3. Now that's a special thing. If you remember with surds, remembering that's a surd, if I have 1 over root 3, it's not neat, it's not nice. So we manipulate and rearrange, and the easy way to do that is to times, we want to get rid of the bottom, and we should know that a square of a square root cancels it out and you're just left with 3. So if I times by root 3 over root 3, that's just 1. I'm not doing anything, I'm just manipulating. And that then becomes root 3 over 3. And that's more acceptable than having the surd on the bottom. Some textbooks leave it like that. I would just do that anyway. Put that down, do that. Either way, you'll get marks. If you forget to do it, you might lose half a mark. If you do it, it may not be worth anything, but at least you don't lose half a mark. So going back to here, that's the same as root 3 over 3. Then we can do sine of 60. These are your exact values. You leave it like that unless asked to do so many decimal places. This is opposite over hypotenuse. Sine of, cos of 60 is adjacent over hypotenuse, and tan of 60 is opposite over adjacent. So it's just root 3 over 1, or root 3. I'll do the 45s later, but just having a look at the 30-60 triangle, we can then go around this and we can have what I call these little trigger values. They're supposed to trigger off a little memory. Some teachers do it as a table. I think that just does my head in. I always think back to this because this is what you're going to be using to solve a lot of problems. So if we have a look here, this here, have a look at what would be if it was 180 minus 30 or 180 plus 30. Here in this, or we could have had 360 minus 30. So these are what I call my little trigger values. That's 150. That's 210. And that's 330. Now these are my little trigger values. If you have a look at these, we've got sine of 150. Now 150 we know is here, and it will be 180 minus 30. I like to put here, that's the same as sine as 180 minus 30. I like to put 150 up there to show where I got it from, which means it's the same as just sine of theta. But in quadrant 2, I always like to write quadrant 2, it is positive sine of 30. And sine of 30 was 1/2. And you can check that on your calculator, and that's it. Well, what about cos of 130? Oh, sorry, 150. That's the same as cos of 180 minus 130 of 30, which is the 150, which is cos of that angle in quadrant 2. So that means it's going to be negative cos of what 30 would have been. And that is minus cos of 30 is root 3 over 2. And likewise, tan of 150, better write that down here. Make it nice and big so you guys can see it. So tan of 150 is the same as tan, split it up, 180 minus 30. I know it's in quadrant 2. That's 150. Now we know tan in quadrant 2 is negative, so it's the same as minus tan 30. And tan 30 is root 3 over 3, or 1 over root 3. So that's it. 150, if you see 150, little trigger point, can I do 180 minus 30, 180 plus 30, or 360 minus something to get 150? So that's your 150. Remember that one. Remember 150, very important. Well, let's have a look at if it was not 30, but 60. Again, we're still in quadrant 2. So let's do minus 60. That is 140. It's not, it's 120. Another trigger point, 150. 120 is important. Let's have a look at that. That's sine of 120 is sine of 180 minus 60, which is 120. Sine in that second quadrant is positive sine 60. And that equals sine of 60 is root 3 over 2. What about cos? Now you're getting the drift here. I'll go through it quickly. If you want more, just give me a message and I'll do it again. So that there will be cos of 180 minus 60, which is your 120. Cos in the quadrant 2 is minus cos of 60, which is minus cos of 60 is 1/2, minus 1/2. And likewise, tan of 120 is tan of 180 minus 60, which is tan. Now in quadrant 2, tan is negative, minus tan of 60, which is minus root 3. And then we go this way. Now if you're looking at the 45, we'll do 45 now. Remember to draw your 1, 1, 45 root 2. Now remember, 45 is also equal to pi over 4. 30 is pi over 6, and pi over 3. Easy way to remember is pi is 180. So 180 divided by 6 is 30. 180 divided by 3 is 60. And 180 divided by 4 is 45. Always remember pi is just 180. And we'll do some more on those conversions later for those who need a bit of refresher. If it was 45, let's have a look at 180 minus. So instead of 60, so we've got 120, 150. What about if it was 45? That gives me 135. Again, one of those little magic numbers. So let's have a look. Again, we're still in quadrant 2. Sine of 135. Check. Is it one of those 30, 60, 45? If they say exact values, look for 30, 60, 45. So if we do here, sine of 45 is opposite over hypotenuse. Cos of 45 is going to be the other adjacent over hypotenuse. And tan of 45 is opposite over adjacent. Now remembering here we've got root 2 on the bottom, we don't like that. It doesn't sit well. So we just move that equals 1. 1 over root 2, you multiply it by root 2 over root 2, you get root 2, that cancels out over 2, which is the nicer way. And again, could be worth half a mark. So here, this is the same as sine of 180 minus 45, 135. It's in quadrant 2, so sine is positive. Sine of 45, which is either 1 over root 2, which you must change it to root 2 over 2. Now cos of 135 is cos, and I always say set it out. My rule is 1 step per line, equal signs underneath, show every little stage of working out. If you go back through the QCAA or any of your exams solutions, they'll show you the half marks you get for every little bit. I've had some students who get every question wrong, still get a high distinction because they've shown every single step. If you just write the answer, you might only get half a mark. The rest of it is in the working out. Always remember that. Your teachers always say it for a good reason. Again, quadrant 2. See how I'm showing everything? 135 is 180 minus 45. Quadrant 2, it's positive. Here, cos is negative. It's the same as cos, negative cos 45, which is minus 1 over root 2, which is minus root 2 over 2. And then tan of 135 is the same as tan of 180 minus 45. Again, quadrant 2 is minus tan of 45, which is just minus 1. We then will do 180 plus, which I'll do very quickly. I won't show all the working out, but you get the drift with your 30, 60 and your 45. And then having a look at 180 minus for quadrant 2, 180 plus for quadrant 3, 360 minus for quadrant 4. So going through very quickly the rest of them. I won't do all of them, but you can fast forward. If it was 180 plus theta. Now remember, we're looking at 30, 60, 45. Whenever you see exact values. So let's have a look at if it was 180 plus 30. We get 210. One of those little magic numbers like 150, 120, 135. So then you do sine of 210. Remember, 210's here. So it's 180 plus. That is the same as sine of 180 plus 30, which is 210 quadrant 3. In quadrant 3, sine is negative. So it's negative sine of 30, which will be minus a half. Cos of 210 is the same as cos of 180 plus 30. Again, quadrant 3. We know that cos is minus cos of 30, which is equal to minus root 3 over 2. And 10, here's the lucky one in this quadrant. That's the same as 10 of 180 plus 30, which is 210 in quadrant 3, which we get positive tan 30, which is positive tan 30 is 1 over root 3, or as we like to say, root 3 over 3. So that's your sine, cos and tan of plus 30 in quadrant 3. 45 was the same. Tan was positive, and you go back to 45. Cos, again, is 1 over root 2, 1 over root 2, and 1. So you do that with 30, 60, and 45. So we're not going to do them. We're just going to have a look at those little trigger numbers. So it was 180 plus 30, 180 plus 60, 180 plus 45. So we had 210, 240, or 230. 2, 3, what am I doing here? 2, 3, 25. 225. Brain's gone a bit funny there. So you got 240 and 225. That's in quadrant 3. What about quadrant 4? This here is 360 minus 30. 360, no, we'll try that again. Jumping ahead of myself. 360 minus 30 is 330. 360 minus 60 is 300. And 360 minus 45 is 315. So, there are trigger values. 120, 135, 150, 210, 225, 240, 330, 315, and 300. And you can work them all out with your exact values. One thing to note, if you have a look here, when you're doing 30 and 60 with a 90 degree, which is a complementary angles, you see that sine 30 is a half, and cos 60, which is the complement, is also a half. Cos of 30 is root 3 over 2, the complement, which is the 60, sine 60 is root 3 over 2. And that comes into some of our proofs later on, where cos theta is the same as 90 minus theta, which we saw there. Hope that helps. And I hope the video quality is getting a little bit better.